All right, here's the second part of the video. So rounding with 1 with compensation, usually again, even on adding, you just want to round 1. It's just easier to know how to fix it or how to compensate. So in this case, again, it's usually easier to round the second number into a friendly number. So 823 minus 200. Again, notice I don't have to do any regrouping, which is what we want. Now, and then you ask yourself, did I subtract not enough or too much? I actually subtracted more money than I was supposed to, like they overcharged me, right? So I need to add that $2 back in, $6.25. And again, you don't always add it, you don't always subtract. It kind of depends on what you did. So like if you did, oh, I don't know, 821 minus say 203, something like that. If you decided to just change that, again, make the second number friendly, that's usually your easier idea, and get 621, then you have to think, did I subtract too much or not enough? And so this person did not subtract enough. They're supposed to pay 203, they only paid 200. So then to fix that, I would have to do what? I subtracted not enough, right? I guess I'm going to have to subtract more. Now the problem with that is then I'm going to have to ungroup at that point. So that's not, you know, again, maybe not the best choice as far as methods go. You know, maybe adding arm would be easier here because 18 and 3 makes 21 and then adding arm. But again, just know that you might have to add or subtract when you compensate. All right, Australian is when you truly do borrow, and I'm going to write this off to the side just in case this helps some of you. So I can't take 8 from 3, so I literally borrow another $10 bill, and basically when I borrow a $10 bill, I get 13. So what I do is I go in debt another 10, so this becomes 100, and I give myself 10. 13 minus 8 is 5. All right. And then again, I can't take 10 $10 bills from 2 $10 bills. So again, this is your debt area. I'm going to go in debt another 100, right? So I'm going in debt another 100. This becomes 200. And when you go in debt 100, you get 100. So this becomes 120. And again, if I go in debt another $100 bill, I get 10 $10 bills. So that's why that becomes a 12. So 12 minus that is 2. 8 minus 2 is 6. And again, you can kind of see it over here. Like you borrowed another 10, you get 10, you borrowed another 100. And then again, all of these are negative. So this is like 13 minus 8. If I do the distributive property, like add, opposite, 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 these are all negative. So I get a 5, I get a 20, and I get a 6. So that's your 625. So if this makes more sense, that's kind of really what's going on there. All right, we talked about, again, the only reason you do any of these is to get friendlier numbers. So sometimes it's make it 10. So like if a kid has 8 plus 7, they might be like, ooh, how could I make it 10? And they're like, oh, I'll break this into a 2 and a 5, and I can make 10 because we know 10 is friendly, and get 15. All right. So again, with little kids, making a 10 is a friendly number. Or like 6 plus 5, they might make it like 5 and 1 here to make a 6, and then they're like, ooh, this is 10, that makes 11. So 10 is a friendly number to make. The other thing that's friendly is doubles. And when we say doubles, we don't mean infinite many doubles. So like if you have 8 plus 7, we either mean double 8s or double 7s. We don't mean 4 and 4, because that makes it worse, right? Like if you have 4 and 4, then you still have to add it together. So I could do a 7 and a 1, and then my doubles are 14 plus 1 is 15. The other doubles I could do would be with subtraction. So like 8 and then minus 1. So 16 minus 1 is 15. So doubles does not mean a boatload of doubles. It means literally one set of doubles, all right? And it can even be something bigger. Like if I have something like this, I know doubles 25s is 50 cents. So I might break it into double 25s and get 53 because I know 2 quarters make 50 cents and 3. But again, it's doubles of one number, right? So if you break 8 into 2 and 2 and 2 and 2, that is not doubles. That's like 4 sets of 2. And then you still have to add them up to get 8. Okay, doubles would be, you know, an 8 and an 8, 7, 7, 6, 6, and so forth. So this is, you don't want to break it down too much. All right, and then at the end of class, we talked about the commutative and associative property. The word commute means move, so it deals with movement, when you move numbers around. And the associative property, like who are you associating with, means who is your group. So this deals with groupings. Okay, and again, only works on adding and multiply. It does not work on subtract or division. And again, we can use these to make life easier. Now again, it doesn't necessarily mean it's like rounding with compensation or anything like that. You're just using these two properties to make life easier. So if I give you like 498 plus 76 plus 2, according to order of operations, you're supposed to go left to right, like get an answer and then add 2. So a lot of times, you know, kids will just be like, okay, I'm going to add those. And then, but again, do you see how if I move this 2 over there, right? If I move it and I make it this, so much easier because I get 576. I don't even have to like do any grouping. I don't have to think about, ooh, should I round with compensation? I just group it together and I move it, okay? So in this case, I guess I really moved it. So that's commutative of addition, okay? And that's legal. As long as you have all add, you can do it. Subtraction, no. All right, and then the same thing with associative would be maybe I have something like 498 plus, and then I have, I mean, 2's not too bad, but I could pick something else. Let's make this 88, make this 12 plus, say, 99 or something like that, okay? And order of op, I'd have to add this first and then add it with this, but I might notice I'm like, oh my gosh, like 12, and that makes the 500, because that would make a 9 with a 10, which would regroup. So if I could just group these together. So if I change how I group it, I don't move the order. Do you guys see that? I didn't move anything around. I kept the order exact. I didn't commute. See it? It's exactly the same. 48, 12, 99. 48, 12, 99. I just changed how I grouped it. That's the associative property of addition. Okay, and that works for multiplication or addition, but it has to be all multiply or all add, and then you can do that. So sometimes you can just use a property to make it easier, right? And again, a lot of the things that we're doing really are relying on properties to work, which is good. So a lot of times you see these in algebra, like, you know, x plus 3 equals 3 plus x. That's the commutative because you're moving it. Where in algebra you might see x plus y plus z equals x and then y plus z. And see how the order didn't change, but you grouped it? That's associative. This one's commutative. But again, you can use them in real life. I mean, they're super helpful. Knowing that you can move numbers around or group them differently is huge. So that's kind of a summary of what we did today. Hopefully that helps, and I will see you tomorrow. Bye-bye.